Hi guys, today we're going to be talking about comparative relational thinking. And really this is just a fancy term to say algebra. Let's get started. We're going to look at four main steps today. Compare, relate, balance, and check work. So compare, relate, balance, and check work. You know, I like mnemonics or something to help us remember things. Um, CRBC, what can we use? Cats rarely bite children. I like that one, right? Cats rarely bite children, okay? So try to remember CRBC as we're going through today's lesson, okay? So first of all, let's talk about something that we typically know, right? So let's talk about the property of equality. The property of equality says, as long as we have this equal sign, right? Anything on both sides of this equation must be equal. So 2 equals 2, is that a true statement? Yes, that's true, right? That's a true statement, right? Let's talk about 300 equals 300. Is that a true statement? Yep, that's true, right? That's the property of equality. What about 524 equals 527? Wait a second, that's not true, right? That's false. Okay, so the property of equality again says as long as you have the same numbers on both sides of this sign, this equal sign, we're good. But when you do not have it, like here, 524 does not equal 527, then this is false. Okay, make sense? Both sides of the equal sign are equal. If it's not, it's false. Okay, let's look at another example. What about this? 2 plus 3 equals 2 plus x. Now, x is what's called a variable. Okay, a variable is a letter, and it doesn't have to be x. It can be x, n, m, s, whatever letter you want. Okay, so it's just called a variable, and it stands for a number. So if I had this equation, 2 plus 3 equals 2 plus x, what would x be here? Well, obviously, x would be 3. Why is that? Because 2 plus 3 would equal 2 plus, and if x is 3, 3. Does that make sense? 2 plus 3 is 5. On this side, 2 plus 3 is 5. Yes, that is a true statement. Okay? Make sense? Good. Let's try another one. What about this? Okay, what about this one? 4 plus 6 equals 4 plus m. What would m be? M would equal 6. How do we know that? Because 4 plus 6 would equal 4 plus, right? And 6. That makes sense. 4 plus 6 is 10 equals 4 plus 6, 10. So that's a true statement. Okay, let's try something that's not so obvious, okay? What if we had this? 6 plus 11 equals 7 plus x. How would we do that? Well, let's think about this. 6 plus 11, what is 6 plus 11? That's 17, right? So 7 plus x, what do I need to add to 7 to make it 17? What do you think? That's 10, right? That's just 17 minus 7, which is 10. So in this case, x is 10. Let's check that out. 6 plus 11, does that equal 7 plus, what did I say x equals? 10. Is that true? 6 plus 11 is 17. 7 plus 10 is 17. So yes, that is true. Okay, so we basically solve this using the addition property of equality, right? So we made sure, right, if one side, 6 plus 11 equals 17, so then the other side, right, equality, everything must be balanced, the other side must also equal 17. We already had 7, right? So in order to get 17, we had to add 10. Does that make sense? Okay, all right. Let's try another simple example, okay? What about this one? 5 plus 7 equals 4 plus x. What would x be? Well, again, using the addition property of equality, let's see what 5 plus 7 equals. What is 5 plus 7? 5 plus 7 is what? 12. So 4 plus x must also equal 12. So what do I need to add to 4 to make it 12? 8, right? So x must equal 8 because 8 plus 4 is 12. And let's check our work. 5 plus 7. Does that equal 4 plus, what did we say 8 x equals? X equals 8. Is that true? 5 plus 7 is 12 equals 4 plus 8, 12. Yep, that's true. Okay, so again, we're using the addition property of equality, right? Just making sure that everything equals on both sides of the equation. Okay, you with me so far? Okay, good. So let's move on. Okay, how about we write the same problem that we wrote earlier? 6 plus 11 equals 7 plus x. Now, instead of using just the addition property of equality, saying, oh, 6 plus 11 is 17, so then on this side, this also must equal 17, so it must be 10, right? Yes, we can do that. But now let's use comparative relational thinking, okay? And in order to use comparative relational thinking, we're going to use these steps right here, okay? We're going to, first of all, compare. Then we're going to relate. Then we're going to balance, and then we're going to check our work, okay? So remember, CRBC, cats rarely bite children, all right? So let's go. So the first step is compare. So what we're going to do is we're going to start with a little star above our number that's on the same side with the variable, okay? We're going to start here. And then we're going to look over to the other side and say, since this is an addition problem, right? This is an addition problem. I can pick whatever number I want to pick to compare 7 with. So would you rather compare 7 with 11 or with 6? Well, 7 is closer to 6, right? So let's compare these two numbers, right? So this is our compare. This is our C. We're going to compare 7 and 6, right? Okay, so what do we do next? The second thing says relate. How can we relate 6 to 7? Right? How can I do that? In order for 6 to become 7, how does it relate? I would need to add what? I need to add a 1, right? Because 6 plus 1 gives me what? 7, right? So that's how they relate, right? So I compared 6 and 7, right? I'm comparing these two numbers because they're closer, right? 7 is closer to 6 than 7 is to 11. 7 is closer to 6 than 7 is to 11. So I'm going to compare 6 and 7. So that's compare. And then I'm going to relate them. To get from 6 to 7, I need to add 1. Okay? And then I'm going to balance, right? I can't just add 1 to an equation because that makes it off balance. So in order to balance an equation with addition on the same side, I need to perform the opposite operation. So if I add 1, where is that 1 coming from? I can't just pull a 1 out of the sky. That 1 needs to come from somewhere, right? And that somewhere is on the same side of this equation. So it comes from this guy, right? So 11 minus 1 is what? 10. And look at this, 7 is now on this side and 7 is on this side. That's great, right? I've related the two, right? And I've balanced, I added 1 and I subtracted 1, so everything's still in balance. So 10 must equal x, right? So x must equal 10. But what is the last step? We need to check our work. So 6 plus 11 should equal 7 plus x. And what did we say x equals? 10. Okay, is this a true statement? 6 plus 11 is 17, right? 7 plus 10 is 17. So yay, it is correct. All right, now let's write our statement, our reasoning. So we're saying x equals 10, right? Why? Because x equals 10 because what number did we start comparing with? 7. 7 is 1 more than 6, right? It was 1 more than 6. That's what we had to do, right? In order to relate 6 to 7, 7 is 1 more than 6. So x must be, must be 1 less than 11. Okay, let's make sure this makes sense. I had an equation that says 6 plus 11 equals 7 plus x, right? I took my first number that's on the same side of my variable, which is 7, right? I compared it with the 6. Why did I choose the 6? Because 6 is closer to 7 than 11 is to 7, okay? And now I related the two. How does 6 relate to 7? How can I change, right, 6 into 7 if I wanted to? I can add a 1 to it, right? So 6 plus 1 equals 7. So now I have a 7 on both sides of the equation. But the third step says to balance, right? In order to balance, I cannot just add 1. Where did this 1 come from, right? I can't just take 1 out of the sky. In order to balance, it has to come from someone. So somewhere. In order to balance, it must come from somewhere. So if I added 1 here, I needed to subtract 1 on the same side of the equation. So 11 minus 1 gives me 10. I checked my work. 6 plus 11 equals 7 plus 10. Is that true? 6 plus 11 is 17. 7 plus 10 is 17. Very good. So x equals 10 because 7 is 1 more than 6. And so x must be 1 less than 11. So in addition, in order to keep my balance, I need to have a 1 more and 1 less. Okay, so that's how an addition problem is. Okay. All right, let's try another example. 5 plus 7 equals 4 plus x, right? We did this one earlier, right? Because 5 plus 7 is 12. So 4 plus x, right? We found that x equals 8. But let's use this comparative relational thinking in order to solve this problem. So my first step is to compare. So I put a little star, right, on the side with the variable. And I want to compare this either with the 5 or the 7. Which one do we want to choose? Well, the 5 is closer. So let's just compare it with that. So that's my compare. Okay, next thing is to relate. How does 5 relate to 4, right? If I want to turn 5 into 4, how can I do that? I could subtract 1, right? If I subtract 1 from 5, that gets me 4. So now I have a 4 on both sides of the equation. Great. Okay, so I've related it. But now I need to balance, right? If I subtracted 1, I need to add 1, right? In order to balance, subtract 1, add 1, add 1, subtract 1, subtract 2, add 2, right? So everything needs to balance. So 7 plus 1 is what? 8. So 8 must be x. X must equal 8. Now, last step, checker work. 5 plus 7 equals 4 plus, what did we say x is equal to? 8. Is this true? 5 plus 7 is 12, right? And 4 plus 8 is 12. So does 12 equal 12? Yep, it sure does. Okay, so let's write our reasoning. So x equals 8 because, why does x equal 8? Because 4, right, this number that we first started comparing, 4 is 1 less than 5, right? 4 is 1 less than 5. So x must be what, in order to balance, x must be what? 1 more than 7. Okay, 1 more than 7. So again, compare. Here's the number I'm comparing. 4, I'm going to compare it with 5 because it's closer. Relate. How do they relate? In order to go from 5 to 4, what do I need to do? I need to subtract 1, right? But balance, I can't just subtract 1. I also need to add 1. Okay, and if I do that, 7 plus 1 is 8. I check my work. 5 plus 7, does that equal 4 plus 8? Yes. 5 plus 7 is 12. 4 plus 8 is 12. So x equals 8. Okay? Alrighty. Very good. Let's move on. let's take a more difficult problem here. Okay, let's go with 67 plus 45 equals 70 plus m. Okay, remember, our variable can be any letter. This time, our variable is m. Okay, first step, compare. 70, what am I going to compare it with? 67 or 45? What do you think? I think we should go with 67, right? So I'm comparing 67 with 70, okay? How can I relate these two? To go from 67 to 70, what do I need to do? I need to add 3, right? If I add 3 to 67, that gives me 70. Great. So my 70s are covered, right? So I have related. This is the R. The next step is balance. If I just added 3, what should I do here? I need to subtract 3 in order to balance, right? So 45 minus 3, that gives me 42, okay? So 42 must be m. So m equals 42, right? Because now everything's balanced. But last step, let's check our work. So 67 plus 45. Does that equal 70 plus, what did we say m is? 42? Is that true? Well, what is 67 plus 45? 7 plus 5 is 12, right? And then 6 plus 4 is 10, plus 1, that's 112, okay? So this side is 112. Okay, 70 plus 42. What is 70 plus 42? 0 plus 2, that's 2. 7 plus 4 is 11. Oh, guess what? Yes, that's also 112. So great. All right. So m equals 42. Why? So m equals 42 because, okay, sorry, because what? 70 is 3 more than 67, right? So m must be 3 less than 45, okay? So m is 42. Okay, so hopefully this is making sense, guys. Okay? All right, we will cover subtraction in our next video. Thanks. Bye.